Likewise, I'm sure this event shall also enrich our knowledge in allied areas of the designated topic. From trial pits to SPT and towards non-destructive geophysical and remote sensing techniques, the methods of geotechnical investigations have come a long way. Our expert speakers and panelists will address the topic with diverse and in-depth perspectives with regards to academics, research, industrial, commercial, codal developments, and accreditations. On that note, we would like to extend a warm welcome to our eminent speakers, Professor G.L. Sivakumar Babu from IISc Bangalore, Dr. C.R. Parthasarathy, Chairman, IGS Bangalore Chapter and Managing Director, Sarathy Geotech, Professor P. Anbazhagan from IISc Bangalore, also Secretary, IGS Bangalore Chapter. We would like to welcome our distinguished panelists, Dr. Anil Joseph, President of Indian Geotechnical Society, Srimati Madhurima Madhav, Scientist D from Bureau of Indian Standards, and Mr. Pankaj Johri, Director of National Accreditation Board for Testing and Calibration Laboratories. Now, I'd like to invite Dr. Anil Joseph to declare the workshop open.
Good evening, all. It's a great privilege for me to be part of this wonderful program of a very important, relevant subject, geotechnical investigation, past, present, and future. So we'll have a lot of technical discussions here. And I, as the President of Indian Geotechnical Society, I take this opportunity to declare the event open.
Thank you, sir. Now we shall move on to the speakers. I'm sure all the speakers are very well known in the field of geotechnical engineering and all people related to the geotechnical engineering field. So now I'd like to welcome Professor G.L. Sivakumar Babu, who is a well-known name in the field of geotechnical engineering. He is a very senior professor at IISc Bangalore. So the floor is yours. You can take up your presentation now.
Hello, everybody. Hello, Professor Dr. Anil Joseph. Am I audible?
Yes, sir. You are.
Am I audible?
Yes, sir. Yes, sir. You are audible.
Yeah, okay. Loud and clear, sir. Loud and clear.
Yeah. Should I start, or what is the plan? Or
yes, sir. You can start your. You can share.
Let me just. Yeah, screen sharing. Can you enable?
Just a minute, sir. Just a minute. Can you raise your hand, please, on the Babu sir? Okay. Yeah, I can share the screen, sir. Now.
Let me just take 1 minute.
Babu sir, before you.
Yeah. I mean, what happens?
Let me welcome all the participants now. So, on behalf of Indian Geotechnical Society, I extend a warm welcome to our President Anil Joseph. He is also celebrating his birthday. Wish you a very happy birthday on all of our behalf, sir, to you.
Thank you very much. Thank you.
So we have today's speaker, Professor G.L. Sivakumar Babu and Professor Anbazhagan, our chapter colleagues, to present our perspective. I also extend a warm welcome to Ms. Madhurima Madhav, representing Bureau of Indian Standards, Mr. Pankaj, representing the National Bureau of NABL, is yet to join. I saw the CEO, Venugopal, sir. Good evening. Welcome, sir. I also extend a warm welcome to all the chapter colleagues who are present here and all the members and the participants logging in, more than 130 people from all parts of the country. So a warm welcome on behalf of the chapter for this workshop. Thank you for joining, and over to you, Babu sir.
Yeah. Is it visible? Is it visible?
You open the file, sir, double click it. I'm only seeing.
Yeah, I opened it.
Not yet, sir. Not yet. You unshare and reshare the screen, please.
Okay, because I'm able to see. Stop sharing. Okay.
Stop sharing. You please.
Okay, I will share
Yeah.
the screen.
Share screen.
Yeah. Is it visible?
Yes, sir. Please continue, sir. Visible.
Yeah. First of all, let me welcome you all for this important discussion on the geotechnical testing, past, present, and future. This is a very important initiative in the context of our geotechnical practice in the country. And my objective would be to just give an overall view of what is the past and the present, in the sense recent past, and what are the requirements. I should say that the works of Dr. Carl Terzaghi, who is the father of soil mechanics, has laid the foundations for the evaluation of geotechnical properties. And in 1936, the first international conference on soil mechanics and geotechnical engineering, he just mentioned that these geotechnical materials are geological materials, because he was the first man who proposed the effective stress. He was trying to identify the problems he had with geomaterials and wanted to give a mechanical treatment or mechanistic picture of how they behave. So he wanted to give certain numerical values to characterize them and to understand them, and then they termed them as physical properties. And he also proposed this principle of effective stress that we know. In fact, in all the this is very different from all the materials where the total stress is equal to the effective stress. But here we have pore water pressure that comes into picture, and that complicates the whole issue. And the other important thing that we should recognize is that the the stress strain response that we know, like, as an engineer, we need the strength and we need the deformation response. And also sometimes the pore water pressure is there, most of the time. So we need to know the flow characteristics. So these three things are interwoven, like stresses, then the corresponding volume changes, right? The thing he said, the effective stress is nothing but the one that controls the volume changes. So the stresses, the volume changes, and the flow characteristics are all somewhat related. We call it as a drained or undrained conditions and all of that. So they cannot, they have to be completely determined, they're dependent on effective stresses. So without proper effective stresses evaluation, you cannot go for actual, proper assessment. That was a basic understanding that, and then that was proved very well. That I think I'll come back to that. Very importantly, we should recognize that in our country, that why do you need any of these investigations, whether it is laboratory or field investigations? First thing is the technical requirements, right? Like, because we need to have the baseline conditions established, like whether it is for the design, construction, and any of them, because you need all your projects, the proposals are based on that. So they provide design inputs and improve the quality of analysis. In fact, if you want to give a design report, like we look at what the parameters are and all of that. And essentially, if the parameters are not evaluated properly, then the design becomes questionable. Then if you want to really develop cost-effective methods in design, whether if it is you look at parameters again. And if you want to do ground improvement techniques, essentially in some cases where it's required, we need to really look at parameters. Say, for example, whether it could be a simple corrosion or friction angle or whatever, and how do you really improve them under what conditions? So you need to know all of these parameters in some sense. And there are some cases where you may have to come up with new mixed designs and formulations. Actually, for example, I was trying to look at a failure of an RE wall, and then the backfill material itself is not available. So you have to come up with a new mixed design that will really duplicate the backfill that was used earlier. So it's something like that. And even to develop new materials, because we are trying to look at, it's a continuous journey in geotechnical engineering, that if you want to really find new materials or waste materials or whatever, you need to characterize them with some certain boundary principles and trying to understand them in a framework. So we need the properties, and then they can be from laboratory and field. And of course, we need to have the complete understanding of the material behavior, because we take the sample, then from the test the lab, and then expected to go through various stress conditions. It can be drained loading, undrained loading, or even earthquake loading, or any other conditions. So we need to understand the behavior of the materials under a whole range of stresses. And also we have a lot of modeling as well nowadays, or even right in the beginning, that of course effective stress itself is a model. So we try to understand them in a simple way, and try to see whether it fits into our requirements. So these are the technical requirements essentially, because we need them for the project. But then what is the ethical requirement? I mean, that's particularly very, very important in our NABL. We have IS codes. We have, why are they? They are all here because they have certain roles to play to make sure that we do this, and because we have to show compliance with the rules and regulations that we have, and whether it is NABL laboratory or IS code or BIS codes and all of that, and provide manufacturing quality control and quality assurance, particularly if you're, say, for example, if you're trying to have a particular product, like whether it can be in a concrete or it can be a geosynthetic material, it should have certain testing parameters that it has to satisfy in the field. Even it can be of course, a quality control, like even construction quality control, both of them. If you want to develop both quality control and quality assurance plans, both in manufacturing as well as in construction, we need to do this. And lastly, I mean, of course, you can add many things. Troubleshoot construction problems. We have seen most of the time that, okay, why is that there is a problem there? Then they go there, they go to the site, and then they say, oh, there is a clay content higher, or there is this content higher. These sort of construction problems they try to really revise and then try to provide a solution based on some of this laboratory testing. Of course, we have forensic and legal requirements, because first thing you need to find, if there is a failure, that you need to find out why there is a failure there, what happened. So then it also tells you to minimize the risk from failure, like the guidelines. The guidelines are meant for that. If you say the soil specifications in a particular site and a particular project, if you follow the specifications properly, there is no problem of failure. And even litigation, like so we have seen a lot of issues there. Like if you have some set of properties, then definitely one can discuss and then look at it, and they are all assisting claims as well. So these are the basic important things. And when it comes to the past developments, as I said, that the effective stress principle was the cornerstone of the development of geotechnical engineering or soil mechanics in those days, it's called. And so there's a lot of tests that were done to laboratory tests to confirm how that principle is valid, I think. After that is actually Tedzagi's effective stress was well validated by the triaxial testing mission, right? So subsequently, what they did was that, yes, the principles were quite interesting, and they're also proven very well. And then they started with, observing, applying the fundamental principles to engineering practice, like, Terzaghi in his practice, he started looking at it and trying to differentiate different types of soils. And then he also borrowed the idea of Atterberg limits. And so there are a lot of field observations as well. Like, in fact, we owe a lot to him, that he introduced a practice of observations along with Peck, right? So the extrapolation of experience to more daring, important projects, because they took up particularly in dams. Earlier it was in dams, and they went ahead and then they're trying to look at how these properties are useful in construction of big infrastructure projects, particularly dams in those days. And the laboratory is a center of all this working condition, evaluation processes here. And subsequently we had in the IISc conference in Boulder, in fact, shear strength conference is a very, very big landmark, conference. In fact, we were all, when we were PhD students, we were reading it completely, papers from Casagrande and others, they were quite interesting papers on that. And very classical papers. So then after that, the application was, it was taken to field projects. where they were able to see that, you can apply, do the instrumentation in the field, like there's a lot of instrumentation of the, dams, particularly Casa Grande, did a lot of work on that, and it was amazing. And after that, in 70s, 60s, they started, particularly in California area, they started working on dynamic soil behavior, like, Professor Seed and others. So they developed, cyclic triaxial testing, dynamic shear testing and all of that, because how do you understand the response of soils under earthquake loading? They started all of that. So they developed varieties of soil testing methods, both in the lab and in the field. And even, if you just look at a little more after that, people are trying to put these design parameters in calculations. People have developed theoretical models and calculation, whether it can be a bearing capacity, it can be a slope stability, all of them were there. But apart from that, they were also trying to look at, particularly in MIT, they were, they were able to develop this concept of risk assessment, even, constitutive relationships, particularly this is pioneered by many people, like, because the 1960s is the concept of shear strength. Then they subsequently, they were able to combine a lot of other equipments. They were able to understand that the stress, strength, deformation, permeability, they're all related. They were able to develop more sophisticated constitutive models, both in the laboratory testing. They developed a lot of models based on the laboratory testing, and the so-called CAMCLE model, and many of the models are available based on those ideas, which are really being proven. They have proved they were very useful in assessment of soft soils and other things. So, of course, after that, we had the specialized materials like geosynthetics, reinforced soils, in fact, flowable fills, and subsequently the era of computational methods and display. Like you're trying to look at, okay, let us just, not only the soil as a material, we also found new methods of improvement like geosynthetics in 70s and all that in 90s. In fact, the laboratory testing, they started having monitoring the stress strain responses and all of that. So the automation was another important development that took place. But then the practice was a little slow, but it has been very good now. I hope it is very important. And I just wanted to I was just trying to talk to one of my, senior top guys, from MIT, Professor Dr. Mar, who is actually a professor of, he did PhD with Professor Lamb, and he was a Lamb student who developed what is called stress path method. I don't know how many people are aware of the stress path method of testing in geotechnical engineering. It came out of MIT, and he was trying to see, you have to understand the stress strain response, the stress path of the soil right from the beginning. The moment you take the sampling to its complete failure. You must be able to understand how the path of the like right in the consolidation and the shear strength space, like we call PQ space or something. How does it really move? So he developed a lot of methods for prediction of the path or the behavior of soils. Their method is actually stress path method is one of the items. And after that, people developed constitutive models. And essentially, why? Because they were trying to do that. They were trying to automate the things. In the 80s and 90s, there were a lot of automation took place, particularly in laboratory testing, even in the field testing. That's what we see in India, because the advantages are too many that we have a complete information with us. And then consistency in all the test procedures and results, and it gives a lot of data in various phases, and you can retrieve the data and more specialized tests as possible. Like, say, for example, if you're looking at a triaxial test, there are so many stress paths that are possible, and of course we are not doing it nowadays because of so many difficulties. But at the same time, that gave the backbone for understanding the soil behavior. And, it was improve the quality of the data analysis. So what I'm mentioning is about the data in terms of the use of machines. Of course, now, preparation of reports. And now, of course, we have a lot of computational methods and easy to work in the lab, procedures and all of that. So things are excellent. There is no problem at all. But what we see is that, yeah, automation is there, but in India, I don't know to what extent it is there. We are not really good. Like, even say, for example, there is a variety of equipment where very good labs have good automation procedures, both in the lab and in the field. Even in SPT, we are struggling to do that, right? I mean, I think IISc code, PIS code, they're trying to work on it. So the thing is, everything needs to be, because the thing is in geotechnical engineering, the errors associated with handling are much more higher. So we need to really look at how the practice can be improved. As I just mentioned, track cell testing is one of the critical tests to understand the response of the soils. But then it is not done properly in most of the cases. Like even sometimes the interpretation becomes quite difficult. Why? Because the rate of strain is not always mentioned. That the forefathers of geotechnical engineering, they had certain ideas about drainage conditions. They developed, they gave good knowledge about the behavior of soil. So if you want to understand the behavior of soil and you have to test it properly. So we have to test and then interpret in the light of established principles that are there. So the geotechnical engineering community should embrace them and teach all the laboratory technicians about that and all of that. The important other point that I always see is that integrated testing, like geophysical testing has to be done first, like, to identify the number of boreholes. I mean, it gives a basis for identifying the number of boreholes. You need to have a good field testing, good laboratory testing, and the inferences. You need to correlate all the data available to provide a valuable design input to the client. Sometimes we just don't follow that. What is your first thing? You have to say in a preamble that, yeah, this is the philosophy of my testing. But then we simply say something. But because you have to, our understanding of the testing is that we'd like to understand the varieties of soils that you're going to encounter and what are the stress conditions that may be there from the structural consultant or whatever. And so even the ground conditions could be there, could be seepage. So we try to understand those conditions and try to do testing. And we have to show that the testing is really appropriate to what is expected for this type of structure. And then even the long-term loading. There are short-term loading, long-term loading, earthquake loading, different types of loadings we have. So the integrated testing, because the physical, undisturbed samples are always not easy, so disturbed samples, we need to have laboratory testing, we need to have field testing, we need to have. So there are so many things that we have. So we need to have that, and we don't. This becomes one of the we do sacrifice that in some cases. But I think with our NABL and BIS being, they're with us or in the country, I think they should stress a lot on this, that it should be properly done, and the correlations of the properties that we see, like. We see that some labs develop their own correlations, and they use some literature correlations for SPT values and all of that. But, the thing is that, of course, they may have the experience. Experience is an excellent thing, but it's not a substitute for the fundamental knowledge. Okay. So the fundamental knowledge coupled with the experience is a great thing. Like, it tells you to come out with simpler methods, which can stand the test of time, analysis, scrutiny, and all of that. So that's one thing that I want to say. And very important thing is that we need to modernize the laboratory testing in the country, definitely field investigation methods. And there should be a lot of emphasis on the modernization. So nowadays IGS has been putting a lot of stress on these things, particularly in association with both the NABL and the BIS. What are the requirements in the future? See, I just want to say that, I'm just returned from a Geo Congress conference where the Professor Paul Mane, who gave a Thursday lecture on cone penetration. It's amazing. that then he gave a lot of examples of how the in-situ testing, laboratory testing correlations are possible. He is an authority on cone penetration testing, and it was nice to see the valuable inputs from him on geotechnical practice using both laboratory and field testing. So the so good testing procedures have become important because of the good. We need to have good professional practice, and they should also lead to fast track constructions. Say for example, say some of the testing methods both in the field and lab, they should be reliable, and also they should enable in the country like I can't wait for a very long time, and they should be possible to come out with some important conclusions of the quick testing. So, and then also avoid laboratory the failures, and so automation of automation of testing is very essential, and data analysis also is it's very essential. Like so, the generation of quality data, instrumentation, prediction models using data analytics and machine learning techniques. In fact, people now, if you look at literature, recent literature, people have come up with okay, how can I use ML and all of that? And people are even in a company which has a lot of data, they can do that. So it's a quite important thing that they have. And other thing that I just want to see that nowadays people are stressing on digital twins in every area. Like say, for example, I have an embankment structure that I need to do a performance assessment. I know the geotechnical properties, I know the structure, and I know the model, I know the behavior in the field, and I also want to look at in the lab. So we have the lab model or the computer model. You have the field model. So they too represent two digital twins. And so you keep on trying to, you have a prediction models in the lab, but you go to the field and then measure them in the field, like because the geotechnical infrastructure assessment, like we have seen a lot of dam failures, embankment failures in the country. And if you don't have, like nowadays sensors are also become cheaper. So there is so much of progress, but we don't have standards in, what kind of sensors we need to use. How do you do that? There are so many things that one can do. And so it is important that we have to embrace these things. And of course, we have now a good standardization, the certification bodies. We have NABL, and definitely we need more geotechnical engineering community trying to understand what is certification as per the ISO guidelines. And the standardization, BIS we have. So they're actually very, very helpful. And then they're very, like, we need a lot of work. We have to work together a lot. And I hope that some of these meetings will encourage all of us to really embrace this. So thank you very much. If you have any questions, I'll be happy to answer. Thank you.
Thank you, sir, for your insightful presentation. Attendees can post your queries on the Google form that will be shared in the chat. These shall be addressed in the later stage of the meeting. For now, let's have a short video from our sponsors. Thank you for your patience. Now we shall move on to the next speaker, Dr. C.R. Parthasarathy, Founder Director of Sarathy Geotech Engineering Services Private Limited and IISc Chairman of Bangalore chapter. I'll be presenting next. Sir, you can present.
Thank you, Nandu. Good evening to all of you. For those who are joined late, I welcome on behalf of Indian Geotechnical Society, Bengaluru chapter for this workshop. We also see some of the sponsors joining, HEICO, ROCKDRIL, Salem Geotech, Sarathy Geotech, and PRD Drill Rig. So welcome all the sponsors to this workshop. Today's topic of presentation, geotechnical investigation, past, present, and future. Before I give the perspective on the topic, I just echo some of those salient points which Babu sir has already said, and how the geotechnical engineering itself has developed over the last decades. Where are we today, and how we are going to move forward in the context of what is required from the site characterization perspective. So in 1950s, we know the understanding of soil mechanics, permeability, seepage, stress, shear strength, lateral pressures, shallow and deep foundations, which Babu sir has already said. Going forward, the next decade, physico-chemical behavior has been studied at length, computer application, finite element analysis. So those days, the computers were very bulky and it was very expensive. It's not affordable and accessible to many people. In 70s and 80s, expansive clays has been studied. Indian Institute of Science have done a lot of work. Professor Subbarao has produced around 17, 18 PhDs. Professor Katti from IIT Bombay has done extensive work on expansive clays. In the 80s, geosynthetics, risk and reliability, water contamination, and introduction to the geophysical applications, which already Babu sir has said. And in 2000, the information technology sustainability. Now, the millennials, the large talent pool of today's generation, has access to information and technology. What they lack is the skill and wisdom, rich experience. So the baby boomers who have already retired has rich experience and the wisdom. I think there should be a transition of their rich experience to the young talent pool who are very tech savvy today. So going forward for the next 50 years, I think we need to work on sustainability. And therefore, there'll be a paradigm shift in the way we look at problems and also the solutions to the problems. In the next 40, 50 years, I think the urban population will grow in an exponential manner, a lot of congestion, and therefore we need to build infrastructures in a very, very difficult condition than what we have today. So in order to come out with some kind of predictive models using the artificial intelligence and machine learning, I think that is the order of the day to assess the risks appropriately and also build the infrastructure for the future sustainably. We require high quality data. So the subsurface characterizations plays a very important role in developing any kind of framework or developing the models to assess the risk and also come out with solutions to the problems. So as far as the site characterization is concerned, for the future, I think the geotechnical problems will change with time, including finding solutions to problems and also the way that we characterize the ground. Newer techniques, strategies are required. Analysis methods. Babu sir talked about the automation. I'll just touch upon in a bit the strategies, methodologies to develop into a smart solution to present and the future needs. So are the geotechnologists ready for this challenge and prepared for these changes? So I leave this question open for discussion during the Q&A session. When it comes to the subsurface characterization, also like geotechnical engineering has also emerged very strongly over the years. We could see the code of practice for subsurface investigation for foundation IS 1892 in 1979 has given out the details of investigation methods, the geophysical methods. Always we advocate an integrated approach of site survey, performing a geophysical investigation, geological investigation, developing the geohazards, and developing the scope of geotechnical investigations and group all the information together and use it to arrive at your ground model or the design of foundation. In the latest version of 2021, IS 1892, has brought out different phases of investigation, including the construction stage investigation and the post-construction stage investigations. These are very vital for the sustainability. As far as the geophysical methods are concerned, we had only the electrical resistivity and seismic refractions. Today, a gamut of geophysical investigations has been included in the codes. The cross-hole sonic logging, the downhole, the MASW, the GPR surveys, and whole suite of advanced in situ testing, the piezo-cone penetration with pore water pressure measurements, the flat plate dilatometer, the in situ permeability, optical and acoustic telewear, and so on. Even the standard penetration test has been touched upon. We had a workshop last year. I think it has culminated into introducing the energy measurements and standardizing the N values in the IS codes. And also the 1892 has given all the laboratory tests that has to be considered post collection of the data in the site. IS code also 1892 specifies the minimum reporting requirement, including the interpretation of parameters. And therefore, complying to the standards is very, very important when we are collecting large-scale data in the growing infrastructure space. So as usual, the methods of investigations includes trial pits. It will be there for several decades, and it is there today, and we continue to do this tomorrow as well. Okay, you have the first-hand information on the stratifications and visual inspection of the soils. You can collect samples and then classify the soils and arrive at your parameters. The manual augers existed even as site engineer 30 years back. I started to use the manual augers, supervising hundreds and hundreds of projects. It continues to be there even today. It's labor intensive and also restricted to in the top 6 meters. Mechanized augers, not very popular. Only very few selected people in the country have these kind of mechanized augers to perform the exploratory boreholes to shallow depths. In the 90s and 2000, most of the infrastructure projects commissioned this primitive calyx type drilling rig with a pool of semi-skilled to unskilled blue-collar staff. Its capability and capacity is limited. Shortcomings will also of this machine results in very poor data acquisition. If you're collecting undisturbed samples, you're not able to push the samples, you need to drive. And so with the standardization of the in situ testing and so on, 70% of our infrastructure projects commission these kind of drilling machines. Okay. Now, hydraulic machines, little superior in terms of the core samples. It will not wobble, it will spindle and rotate at an axis, and then you can get little high quality samples. But again, it's limited by its capabilities when we are talking about large scale infrastructure projects to explore deeper depths. So these different kinds of in situ testings are not standardized, and therefore it requires standardization of those in situ testing. So now the codes have brought in these standardizations, which benefits for all of us. Now, some of these hydraulic machines have been modified to include these automatic hammers with a guide frame. And these are imported rigs from Italy. L&T commissioned these machines on the high-speed rail projects. There are local manufacturers who has replicated these machines, PRD, for example, and there are a few more others. I'm not sure because we have not worked on this machine on this performance. I'm sure it will have equal performance as the other machines as well. So we imported this machine from US. The point I'm making is high-speed rail project commissioned and wanted these kind of machines to be deployed on the projects because they set a very high standards of specification, conducting SPT test, energy measurement, calibrating the rigs, collecting large diameter undisturbed samples by pushing the samples, so on and so forth. I remember in one of the videos that's there in the social media, the minister is presenting on the high-speed rail project because it's fast-tracked. Progress has been marvelous. High-speed construction, quality control, stringent measures. He also said, our Prime Minister Narendra Modi ji has told, let us not look at this high-speed rail project as yet another construction project, but this is the way that we're going to do the work in the country in the future. Now, coming out from the high-speed rail project to other infrastructure projects, the state level infrastructure projects to the local municipal corporation level projects of the bridges, flyovers, and so on, the stringent requirement of the specifications dilutes in the order that I just mentioned. We talk about one nation, one policy. Why not we have one nation, one specification for all the infrastructure projects? So these are very much essential for the future when you are talking about the sustainability. So currently, the engineers is in a dichotomy of delivering the project goals as well as meeting the sustainable goals. So in order to develop the models using artificial intelligence and machine learning, we need to have high quality data. So I just read an article in the IGS News, volume 51, 2019, by Professor Naresh, Dr. Varun and Uday from IIT Mandi. They talk about the machine learning and geotechnical engineering, also emphasize that they require high quality data. So whatever the data that we have the last few years, I'm not sure if all of them are useful for our requirement for the future. Maybe there's also a need for digitize those data and set a minimum benchmark on the quality of data that we can use it for training the models to predict the risk and also build our future infrastructure projects. So in the next 5 to 8 years, the geotechnical service industry is growing at a CAGR of about 6.5 to 7% with the $3 billion of the market size. And therefore, even in India, the government of India has made a commitment to invest $1.5 trillion of the infrastructure pipeline and build a lot of infrastructure. So it's a time for us, all the profession, to come together, adhere to the standards, and also adhere to the accreditation process, which ensures that your standards are adhered to, collect high quality data, performing the in situ test, exploratory boreholes, collecting samples, sending it to the laboratory, and also automate some of those processes. And the next 3 to 5 years, we are able to do that, supplemented with the data that we have collected in our last several decades. We need to digitize that. And then you see what is usable by benchmarking the minimum standards so that we'll be able to train some of those models using the advanced methods. Now we try to build in our projects the app where the user logins into the app. We give access to the customers also this app. Okay, you can see the different projects going on, the active boreholes, notifications. You can manage projects. What are the machines that have been deployed? Daily reports. Also entering new information and borehole details, including GPS coordinates. That is very important now. And entering the sampling details while performing the in situ test. For example, this is an SPT, and also you can view over the depth. So this is today's information which ongoing site, 3 to 7.5 meters SPT in one of the local projects in Bengaluru. It's a Godrej property. And then you can get the output versus depth and can go inside detail to see more information. You can also see in the app that you can look at the previous projects, the ongoing projects, and get all the details. Okay, and also the boreholes from those projects can be viewed. You can get the stratification, the information available. So this eliminates some of those manual thing into an electronic format. We also have to focus on safety. That is also included in our IS 1892. So the toolbox meetings for all the staff involved in the projects to have the safe practices. And performing the geophysical methods, the downhole. I'll not go into detail of these methods. Maybe the other speakers will talk about it. in situ testing. So these are all the advanced methods required for every project that we perform. And Babu sir also talked about the laboratory testing. So after you collect high quality data, then you send the samples to the laboratory with a lab test assignment sheet, and then you develop the test results, integrate the information collected in the site by in situ testing, by geophysical methods, the laboratory testing, and then bring out into a common platform. So it is very important that the data is portable to a common platform in a common format. I think IGS as professional body together with Bureau of Indian Standards and the NABL can facilitate that the people can send information where the data can be made available, high quality data in a standard format and at a standard place. So people who need that real data for their future research could be requesting IGS to provide the data. So my request to all the principals here to come out with a common specification across length and breadth of the country. So thereby we are collecting high quality and large database that will be of very useful in the future to train models and assess the risk and develop a sustainable future. So with this, I conclude my presentation and we will have the question and answer sessions. Now, I think I'm running out of time. So 10-point summary, one nation, one specification for site survey, and also develop an integrated approach, adherence to standards and accreditation process. We need a lot of skill developments, regardless of the kind of machines that you have. You also need the kind of tooling, you need to have the consumables, and the people who drive those machines has to be really skilled, both the machine level, the supervisory level, the lab level. So we lack that. Migrate to electronic methods, locate GPS coordinates so we know exactly where we are collecting the information, automate many of these processes, including the operations, the mobilization, the field investigations, the in situ testing, then port this information to seamless transition to the laboratory and also the reporting. Digitize the existing database and benchmark the usable ones. So we need to set a standard. AI and ML, I already talked about it. Develop the robust data acquisition system into a GIS platform and transmit the data in the standard format. So our ISSM GE 309 also has initiative into this ML machine learning. So they have the students competitions, they have some task forces, they're working towards it. And therefore, there's a need of ours for us to collect high quality data and use them for predicting a sustainable future. Thank you very much. Nandu, over to you, sir.
Thank you, sir, for addressing the various aspects of evolution of geotechnical engineering. I'd like to remind participants to drop their queries on the Google form chat in the chat box. Meanwhile, Professor Anbazhagan, kindly raise your hand on the chat so that Dr. Partha can make you co-host. Sumant, can you play the video? Thank you, Sumant. Next, I'd like to call upon sir, you're on mute. Next, I'd like to call upon Professor Anbazhagan, Secretary of IISc Bangalore chapter and esteemed professor in IISc Bangalore. Kindly, over to you, sir.
Yeah, thank you. Good evening to all of you. I start sharing my screen. Okay, so now I hope it is visible to everyone. My voice is audible.
Yes, yes, please continue.
Okay, yeah. So before starting my presentation, I thank the IGS Bangalore chapter. So because about 2.5 years back, we have been started the codal discussion. So where now we are almost close to the code drop. So I thank my code committee, the Madhurima madam and Balakumar and Anil and Sanjay, and then a few more colleagues. So where the IS 2131 is going to come with the auto trip update and all those things. So I hope this presentation also brings some other direction to the geotechnical practice in India. So today I'm going to talk about the soil investigation and interpretation of the design parameters. Are we in the past or future? So based on our work, what we have done at IISc. So I'll be talking about the important design parameters and how the C and the 5 we estimate, and how the soil stiffness we arrive for the settlement calculation. So how the soil particle shape plays your role. So what was the role of hammer energy on soil properties, and how the in situ measurement of the stiffness and thickness play a significant role with the future perspective on the Indian practice. So as we all know that the geotechnical practice started with the understanding of the shear parameters, since the soil is fail in shear when compared to any other materials. So where we get enough leverage of strength in the beginning as well as at the end. But in spite of that, due to large deformation, so we limit our criteria by the settlement. So any other material, if it fails, basically it collapses or the brittle or whatever happens in the soil, still it has a strength, but because of the large amount of the deformation, so we don't only consider the strength parameters as a failure criteria, we also consider deformation, that is settlement. Okay, so as we talk about the strength criteria, so most of the other materials we talk about the Engg's modulus is the predominant factors. In soil mechanics, we call the strength criteria as the cohesion as well as the angle of internal friction. So why? Because the shear strength of the soil is completely controlled by the C plus sigma tan phi. So it depends upon the condition. So we go for the effective or total stress. So eventually the C and sigma tan phi is the important parameter to arrive for any design in any geotechnical design. So which is like a failure state. But the initial part of that, we also account to the modulus, which is called the initial modulus, or a kind of the tangent modulus, which is required for most of the modeling purpose. So with this condition, most of our the bearing capacity requirement, because in our country more than 85% of the buildings are in actually the normal building. Normal building means the buildings which is ground plus 3, 4, where the isolated foundation is predominantly used. So we go for the bearing capacity and the settlement estimation as per the IS 6403 as well as 8009. So if you look at the bearing capacity estimation, so we use here the well-derived bearing capacity formation, so which is given from the code, where the CNC and the N gamma and the NQ factors are very important for the soil design. For example, the NC, NQ, N gamma is the bearing capacity factor, which is the function of the angle of internal friction and the passive and the active earth pressure, the constant derived by the Frankel. Okay, so the other parameter which directly relate to the soil is actually cohesion of the soil, the bulk unit weight of the soil, and the effective surcharge at the base of the soil, which is unit weight and depth. So by looking at all these parameters, so we can understand from this one that not only the C and phi is very significant, we also need a unit weight of the soil, which is also play a significant role on your overburden pressure as well as the pressure distribution below that. So in the code, very categorically say that the bearing capacity formulas are many are exist. So most of them are incomparable or comparable. So by considering that, the designer must therefore record the method aid to design, which cannot be replaced a critical role of the engineering judgment. That means the geotechnical engineer plays a very significant role to design what parameter we need to adopt. But most of the geotechnical engineers, in order to safeguard or to make themselves the safer location, so most of the time they take factors which is given from the IS 1604. In our country, as per my understanding of the different project and discussion with the various stakeholders, so most of the design is predominantly controlled by the SPTN based. There are very few projects where they go for the shear strength measurement in the lab and use that for the design, but most of them are taken from the like NC, NQ, and gamma is taken as the function of your angle of internal friction, which is again obtained from the standard penetration test. So this is the typical table given in IS 6403. So where they say that you can use NC or N effective, depends upon the condition, where you can modify the values by multiplying 0.67 into tan phi. You can take it for the design. They give it for the cohesionless soil, what is this one, and then cohesive soil, what is the parameters. But most of the time, the graph given here, left side, is predominantly used for basically to arrive a pi value. From the pi value, they get a bearing capacity factor. Okay. So this graph, if I understand very correctly, I think that since the beginning of the code of the 6403, I think it remains same. Okay. So I had doubt that how this has come and how far it was relevant to understand and applicable to ours, because it was been predominantly used by most of the designs in the country. So when I look at the several the literature, finally I landed with that. It was actually derived by the PEC. Okay, so in 1960, those days, and then it has been produced as a foundation engineering book, basically. Okay, so this is the original curve, which was given by the PEC for the all the this one with this. So he has also given the what kind of the N it refers in the figure, and what are the corrections it's applied and where it is applicable, which I am not going to in detail, but it is available in the sections 5.6 in the same book of the PEC. So if you compare this, which very clearly is actually derived for the cohesive soil, predominantly on the sand. Okay, the sand with the different densities we are taking into account, it has been designed. Okay. So the second part of our foundation bearing capacity calculation is the settlement. So as you know that the settlement, we deal with the two parts, the initial settlement and then the secondary settlement. The initial settlement predominantly controlled by the elastic modulus of the soil, or the cohesionless soil settlement is calculated based on the Young's modulus. The second settlement is consolidation settlement, where the CC, the coefficient of consolidation, the factors which has to be done. So most of the time what happened, so the people there also predominantly use IS 18009. So where it deals here, the settlement happens on the normal condition, and the standard does not deal the catastrophic settlement for the as a foundation loaded only for the bearing capacity. So this point has to be stressed. So when you design your building for the seismic zones, okay, particularly the northern part of the India, so where the possibility of earthquakes are very high. Okay, so where this kind of settlement calculations, whatever we consider, it's only for the elastic and not for the catastrophic settlement. Okay, so that was a hint the designer has to follow, but most of the bearing capacity estimation, the settlement they go for as per this code. So where they take again the N value as the footprint for the calculation of the settlement, and finally they produce the settlement calculation from this graph, which is basically given in the IS 18009. Okay, so I tried to validate this settlement part, is how it has come and what was the background. Unfortunately, I could not able to trace it. So, but I understand from the theory as well as the literature. So generally the elastic settlement predominantly controlled by the Young's modulus and the size of the footing. So where it can be arrived for the unit pressure, where it has been given as the function of the M. So being said that, so this is almost the uniform practice in the country. So here we can understand that the C and phi and the Young's modulus, so which is associated with the other parameters of the density and the thickness of the layer, and the layer should be uniform. So all those assumptions has been taken into account to arrive the SBC and other things. So we are very fortunate that at least the recent attempt has been made to revise the 2131, where the standard practice of SPT being actually kind of try to improve. The predominant the change which we are going to take place is actually the height of fall has been brought to the 760 as per international standard, and to bring the proper efficiency of the hammer, the auto trip has been suggested. So the overburden and dilatancy correction, the formula has been incorporated in order to avoid the error in the graph reading and other things. So the option for the energy measurement has been given this one, so that anybody can arrive the N which they want, basically the N55, N60 and the N75. N60, most of you may be knowing. So most of the bearing capacity equation actually not N60, which was N55 or N70 or 75. N60 only used predominantly in the liquefaction. So the practice of testing is one aspect which almost we are advanced, or we are able to adopt a modern technique equipment and also the measuring tool, so which is helpful to get this one. But that will only resolve our geotechnical issues in the country or make an adaptation. So according to this one, it's no. So why? Because I will tell you the reason behind that, why we should not have the uniform chart in the country or uniform graph in the country. So second is that, so we most of the graph and correlations or whatever relating with the N or anything, we just adopt from the textbooks. The example I have given you. So there are several such kind of correlations are adapted in the design because it is given in the textbooks. The textbooks are written for the understanding the subject by the students. It is not for practice. So the practice is actually depends upon your own soil in the region, your own site condition. So everything. So when you do that, you also need to understand that how these parameter changes with your testing procedures itself. Okay, so how it's insufficient to represent the subsurface imaging or the profiling of the subsurface. So I did a kind of the collection or the summary of the boreholes of the different part of India. So we covered almost whatever dots are given, no dot and also so reasonably well to represent that. So you can see that these are all the log borehole. You can see one thing here. One is that your thickness of the soil is not uniform in the country. The first part. The second part. So the soil, even though you can call silty sand. So these soils are geologically and mineralogically and morphologically are completely different. If you even say that silty sand as per the grain size distribution, which is not uniform in throughout the country, because it depends upon where the soil was origin. So how the location was geologically modified, how it was transported, how it deposited, how it was basically undergone a weathering. So all those processes decides its particle shape and size. So these are again the typical borehole collected from different part of the country which we have. So the India has a heterogeneous soil deposit, so which can be grouped into several major category. So but most of the time what we do, we group into that in the simple classification system which is adopted in the international practice or something for the easy going. But the behaviors are completely different. For example, the alluvial soil, which is shown above, here you can see both are alluvial soil. So both named as alluvial soil can be classified as SM or SC, but they behave differently and the same density of the same soil will have different strength. So similarly, the hilly region and the desert region, the red soil and the black cotton soil and lateritic soil. So grouping them only based on the size, okay, not accounting the shape of the particle or morphological particle. Sometimes we may lead into the wrong interpretation of the properties, which can be evident in some of the failures even in Bangalore, because Bangalore, the lateritic soil, which is less than 75 micron, which has a prone to possibility to migrate along with the water. But when you consider 75, generally we ignore that as a fine-grained soil, since the cohesions are not so much. Okay, so such kind of scenario, the understanding of the morphological particles are really very important. So in that aspect, we try to see that how do we do morphology? Morphology means like the particle diameter, aspect ratio, the radius, and all those things. So we kind of seen that generally people don't look at a particle size below 2 mm because it's very difficult to see by your usual eye. if you want to go for the SEM, something, it's very costly technique. So we come up with the idea of look at a fold scope. This is the fold scope. It's very cheap. It's $1 in US. Maybe India, it was slightly 150 or 200 rupees available in the Amazon. So where your mobile and fold scope can be clubbed together, where you can see the particle shape, okay, with lower cost. So the cost what we talk was actually for the SEM technique, same thing. If you look at it, you need to spend 3,000 rupees, 3 to 5 days. So where the fold scope, you can get 150 rupees is the cost, where you can do it on 1 hour. So where you can get the morphology of the particle, particularly the aspect ratio, size, like different direction, what is the size. Then you get also the roundness. So because as you know that the same density of the irregular particle and round particles are completely behave differently. So such kind of the approach will help to identify, even though the same soil classification in the system, but it behave differently because of its particle dimension as well as the morphology, which need to be accounted in our the geotechnical practice. So the being said that, then another usual aspect is the fold scope can be also used in the field to know your soil, this one, because the gradation one which you do normally see, but after 2 mm or something like that, everything counted as like passing 75 micron or something like that, which we don't do in detail study. So when I talk about the field investigation, generally we have to do the investigation, but which is kind of the actual scenario where the controlled environment is not possible, where the N is used to estimate a relative density, but eventually, as per my knowledge, I never seen that anybody was controlled experiment was done showing that this is the density I feel, this is my relative density, and this is my N value. So in order to reproduce such kind of things, why? Because the hammer energy measured in the field has a lot of impact on the design parameters. So one can create a more N value by applying less energy. One can create a less N value by applying more energy in the same site. So with that, so we create a model at IISc. As you know that the SPT-EMA is our development, which help basically to understand hammer energy at a different level of the borehole, where we do apply a lot of corrections like the overburden correction, energy correction, borehole sampler, rod length and all. So overburden is the soil factor. The energy presently we measure at the place where you get basically below the anvil. But in practice, the below the anvil is actually we measure a property below the ground some depth, like 5 meter, 10 meter, or it depends upon the requirement. But we measure energy at the top. That is the practice because every relation was developed on that. So we understand from the EMA, so try to get the properties of the different depth, bottom, like close to the sampler where you get a sample as well as measure the properties. So we have seen that there is a huge variation of the energy delivered to measure your properties or N count measured at a top location. But unfortunately, now all the relations which is available N versus other parameters are based on the top energy measurement. There is a need to relook at it. We should also measure a property at record depth and relate that energy to the properties. Okay. The second aspect we miss in the field investigation is the rate of loading or blow rate. So how frequently you hit the hammer, which changes your the resistance values, particularly the soil are subjected to kind of the buoyancy effect or dilatancy effect, which need to be accounted. So internationally, this suggested 20 to 40. So, but in predominantly our observation source from several parts of the country, so where we have basically predominantly less than 20 in the blow rate. So the automated or machine one can give the improvement for that. So these are all the basically the variation of the equipment what we tested part of our research, different rigs and the different setup. You can see that the energy ratio what we apply, it varies from around 20 plus or minus to 85% in that. So being said that the correction of this is one aspect. The second is that when you use any kind of correlation or getting a properties, one has to also know that these affect consistently your result. For example, this is the graph shows how the energy ratio. For example, my N value remains constant. So, but my energy ratio is depends upon the equipment and type what we use. You can see the huge difference in the property interpretation or estimation. So if you don't know what correlation you are using, what correlation it was developed for the energy ratio, you will be ending up in the overestimation or underestimation. So many times it lead to the non-safe design. So the most of the corrections what we practice, the predominantly which is controlled by the overburden and the hammer energy. So which if you take care, basically, you can address your design parameter estimation. So this is the data where we measured hammer energy at a given site and the same depth where the properties are measured by the alternate technique. Alternate technique means like the shear wave velocity, density of the sample, shear modulus calculated. So similarly, but Young's modulus, we are working on that. So these are published in Soil Dynamics and the Earthquake Engineering Journal. So the practice of using correlation, it's not only exists in our throughout the world, people are using such kind of empirical correlation to simplify. So starting from the Osaki and then all those. But when we do such kind of correlation application, we should remember that one has to check that correlation condition applicable to our site with respect to soil. Second, the equipment and the end correction practice. The third is that so how these correlations are really correct. So some of this figure basically shows the shear modulus correlation, very famous correlation given in the Ishihara book. So used in the shake and the deep soil software to estimate dynamic properties of that. So basically these are all completely deviate and some of them even the 100 times lower than the actual values. So even this was brought to the Professor Ishihara knowledge. So he has actually said that it is what I say, given correction was correct, but which was published in the Soil Dynamics and Earthquake Engineering. So such kind of the in-depth understanding is needed before using any textbook correlation. That is what I want to impress. So the recently we have given the correlation with the function of the N and with the energy. Okay, so why? Because when you do shear wave modulus and N, the factors were different. When you use only the correction factor and the N, the factors are different. So in order to account such kind of things, the in-depth understanding and the using of any correlations are essential for the best practice. So, and the third one is, even though sometime what happened, we group them based on the region. For example, we say that the correlation developed by Southern India or Peninsular India is this, which is matching that. But it's not that always true. For example, the Bengaluru being a residual soil, Chennai being an alluvial deposit, Coimbatore being a residual soil, the same, the N and the number will give different VS values. So this is what the some of the explanation where the site-specific measurements are very important, which is essential to bring the good design parameters, how the different correlations are behaved. So this is the kind of the bulk density versus N and VS value. So most of the time, the bulk density or density what used in the SBC has been assumed based on the range which is given by the PEC. But one can also use such kind of correlation to get a bulk density which is needed for the SBC estimation. So most of the time, we will restrict our test only in the field or in the lab. Very few studies we can see that both are synchronized. So it is always essential to synchronize our test the similar kind of property. For example, if you measure the dynamic properties at the field, you should also bring the sample and test it in the lab as much comparison. Try to see that how the results are synchronized, which confirms that the property what you give is more reliable. Okay, so similarly the Poisson ratio, most of the time they assume for this parameter, very few people estimate, even though for the very important projects and all. So then the model parameter which we use, so like the shear modulus damping curve, which is needed for the dynamic soil structure interaction or seismic soil structure interaction, mostly people use a standard curve for like seed and trees and other things. So we found that, as I said, that the particle shape plays a significant role. So the Brahmaputra and the Manu River sand, even though the both are classified as a sand, you have a very significant difference in the curve, the upper bound, lower bound, if you see, which is completely differ from the seed and trees. So eventually, this kind of studies are previously not done. So where we are kind of emerging that technique and using the very advanced equipment called resonance column cyclic triaxial, which is available in IISc, where we developed for the several projects, which has giving very promising results. Okay. So this is with respect to in-situ test and this one. So most of the test what we do SPT is bore log based one. But in urban scenario, most of the urban scenario are the soil deposits in India. So there is very clear difference between the understanding the horizontal uniform. Okay, so such kind of assumption. Why? Because you see the typical profile which is available. So in this case, going with the borehole technique may not be sufficiently to capture the result. Depends upon the project. One can adopt an integrated approach. So the integrated approach means you can use the possible available geophysical technique, depends upon the project, and try to get what information you needed for the design. So most of the design required a thickness, stiffness, and density, okay, which can be easily measured by the different technique of ground penetrating radar and the seismic borehole. For example, if you want to do the tunneling, the rock property, one can has to go for the crosshole technique. So if you want to get the average properties above the bedrock or up to the bedrock, one can go for the seismic surface wave technique. So you want to get a diagonal properties, which is required for the average unit weight, average stiffness, one can go for the downhole technique. So depends upon the technique, one can integrate. At any technique, you should not avoid a borehole, because the borehole is the only technique which can give you the soil where you can feel and sense what type of soil, how it to behave. So with the limited the borehole and integrating with the geophysical technique, so you can create a profile which can be kind of 2D, which can predict very well the settlement as well as the bearing capacity if you adopt the in-situ nature of the reservoir. So this is the typical the field setup. What we have done.
Kindly conclude in a few minutes.
Yeah. So done for the metro project. So this is basically helped to solve some of the unknown hidden problems in the metro. So where the tunneling operation is being carried out using this safely to cross some of the important buildings. This also compared post metro profiling, which was matches very well. Okay. So the similar kind of approach we also kind of trying to adopt for the liquefaction, where the low magnitude, less than 6 created liquefaction in the Assam. So where the Tripura was this kind of earthquakes are happening. So the understanding and the comprehensive development of our region specific models like CRR versus number of cycle for that particular soil, which is essential to bring into the practice of the geotechnical aspect. So the being said that, so one aspect is using the code, but the code gives some kind of parameters, which is most of the time taken from the textbooks or from the some other code which was referred. But in our country, we have different regions of the different soil. So there is a need to basically develop our region specific, the soil correlations and models, and use that in the practice. So like a settlement chart, bearing capacity chart, correlation between the N and different parameters on that particular region. So basically since the IGS distributed throughout the country, so which will be very easy to locate, define a methodology and enhance the testing facilities and share the facilities and give the theme saying that these are all the steps you should follow. This is what the provision is given. Finally, come up with the chart, and there is for the bearing capacity, settlement, or any correlation of any specific region will be more appropriate. Why? Because the using of the regional data is not new. So if you look at the olden historic constructions of temple, all of them are standing without any failure. Why? Because they used to do the site-specific soil investigation in the name of Bhumi Puja, where they check density, stiffness of the soil, thickness of the soil, as well as the chemical properties, which is very classical examples one can give. So where the site-specific or region-specific approach of the measuring the properties are very important. So with that, I will thank all my mentors and my students and project staff who are extensively work on this field-based research. So I also want to bring to your attention that we have arrived a first-time design spectrum of the IS 1893 using the Indian recorded earthquake data, which is the normalized smooth design spectrum. So I thank one and all. I will be open to discussion. Thank you very much.
Thank you, sir, for extensively addressing the investigation techniques, improvements brought in, and the possible future of geotechnical investigation as well. You can conclude your screen share, sir.
Yeah. Mine is over. If there is any question.
Unshare the screen. Unshare the screen.
Thank you. Participants, you can post your queries on the chat box. I mean, there is a link, Google form link in the chat box. You can open it up and drop your queries. It will be addressed at the last. Sumant, can we go ahead with the sponsor video? Thank you, Sumant. With that, we come to the conclusion of the speakers. Now we'll have the panelists speaking. First, I'd like to invite Dr. Anil Joseph, Managing Director, Geotech Private Limited, and President, Indian Geotechnical Society. Over to you, sir.
Yeah, good evening all. First of all, I would like to congratulate all the three speakers for covering in detail regarding the past, present, and future of geotechnical engineering. And it's very important, geotechnical being such an uncertain element. Even if you do the boreholes and the data, I always say the geotechnical interpreters are like magicians. So you have a probability, if you put the probability statistic into this, you take a borehole in 1 point in a 10 cents of land, your probability is 1 by 25,000. So that is where you are interpreting that one data to 25,000. And if you take 2 points at different place, the probability is about 12,500 is the probability 1 on 12,500. So it's such a small number and you are expecting that everything is similar to that. So that is the uncertainty of geotechnical engineering, where we have to do the magical job of interpreting the data with these 2 points and conclude that this will be the same behavior, which can vary both horizontally as well as vertically in between pockets can be there. So the need of proper investigation and proper testing has been highlighted, and especially Anbazhagan has pointed out the importance of having the energy aspect and how it vary and the standardization of the test, which is not there. I, for one, is a big advocate of bringing up a soil profile data bank across the country based on the latitude and longitude. Good data has to be collected. This is something which we are now mooting in the IGS National Executive Committee meetings, where we have to come up with data. But there the problem is that people believe that this data will be misused. But then if we don't collect big data, because big data is the future, and I believe that artificial intelligence and machine learning is going to take a huge change around in the investigation activity in the near future. The time is not far, with about 2 lakh snaps, they will be interpreting what is the, or the cross-hole profiling getting advanced. They will be telling that what is the type of soil without doing an actual borehole. But then we have, it is a long way to go. There is a lot of interaction needed, a lot of study needed. So we strongly believe that the data profile has to be developed, data bank of soil profile, like Anbazhagan has pointed out, where he has collected data from different area. But since this is varying so much, that we should have a proper latitude, longitude formation, which can be used for further research and activity. And it is one of our goal of the IGS to have this forum in place. And also we are trying to come up with something called Indian Geotechnical Institute, who will be the division of the Indian Geotechnical Society, who will be focusing on the consultancy and upgrading the activity in the field so that our skill sets improve. Again, Partha pointed out the necessity of skill development. We have people who are operating are not trained, or there is no certification mechanism. I would like to inform you that we have made a tie-up with a skill development forum to come up. IGS wants to come up with an activity where we will be giving training to the people. The discussions are in the initial phases, but we will be coming up with the activity and the chart so that we will be certifying the people. Say someone is skilled and trained in static cone penetration test, or someone is skilled in pressure meter test. So those sort of specific tests with the guidance and what has to be looked with the hands-on training, if we can give them, and they will have a better prospect of job, and our quality of work will also improve tremendously. So that is another aspect. Of course, we would like to work along with the accreditation NABL team to improve the system of testing in the laboratory, which also has to grow leaps and bounds. And we have to correct that. And with the NABL on, at least certain standard systems are getting done, but we have to highlight the importance. And because India being such a huge country with so much of need, we have to increase the number and we have to work closely. The Bureau of Indian Standards definitely has to give a lot of importance. And I say that I strongly believe that we should make it compulsory for any building exceeding 3,000 square feet. As per we should have a statutory rule that geotechnical investigation has to be done properly and vetted by a professional geotechnical engineer, because it is not only for the more job opportunity for the engineering fraternity, but it is very important from the safety aspect of the buildings which are being constructed. Now, we also heard the problem of Joshimat singing, and we realize, and when people, now two of our National Executive Committee members are part of the investigation, and like our Revijakka and our professor from IIT Roorkee, BK Maheshwari. But then what the data they are getting is that even 6-7 story building doesn't have a soil investigation done. So why for that? Why we are allowing them to do that without a proper study is a big question which has to be addressed. And yeah, Madhurima is here. So you have to come up with a system. We have to make it mandatory, and we would like to work closely with you, because we have many people now working, but all has to be coordinated, brought into umbrella, and a statutory system has to bring in. Or from the government level, you have to come up with a system of collecting data bank, like the soil bank or the maps we have. Soil bank data we have for the agriculturals. Like that, we have to come up with the soil bank data of the geotechnical investigation, and has to be cross-verified, and government has to take the initiative. IGS also would be like to part of that, so that the better knowledge and details are available for people to do the projects, and risk can be avoided. Again, mandatory system has to be brought in as part of the building rule formation and national building code also. And now there is a proposal to have for all the major projects a geotechnical engineer on record. And I would also like to add that there has to be preference given to the members of IGS, because it's a statutory compilation. Like, we will also like to screen them and make sure that we will be doing a good job to get the safety done. But I would like to congratulate Partha and team IGS Bengaluru for coming up with a very relevant topic, past, present, and future. And I have been given a allotted time of 6 minutes of getting over, but I would have liked to talk and discuss on that. We should have the panel discussions, and we should discuss, debate, and make sure that we are not just limiting us to seminars and discussion. Let us bring it into practice and make sure that we brings up with safe structures, with proper code followed by the guidance given by Madhurima, proper lab test done by Pankaj and team, and the national building code or skill development should be also be brought in together. Let us come up with because there are not so many compartments. Like DFI is there. Let us all work together to come up with a safe and strong structures in India, and where definitely geotechnical engineering has to do a great job. And from the team of IGS, I am sure that all our support are there with you people. Thank you very much for the opportunity.
Okay. Thank you very much, sir, for sharing your thoughts. I next request Srimati Madhurima Madhav, Scientist D, Civil Engineering from the Bureau of Indian Standards, to share her thoughts.
Good evening, everyone. I first of all thank IGS Bengaluru chapter for providing me this opportunity. I would also particularly like to thank Sivakumar Babu sir, Dr. Anil Joseph ji, Parthasarathy ji, and Professor Anbazhagan, who have been all involved in our various technical committees relating to soil and foundation engineering. So very important points have been made today. Babu sir talked about professional ethics. Parthasarathy ji talked about the need for skill development, and he also talked about one nation, one policy, and Joseph Sav also made a very valid point that the regulations which are there in the country, they should include the provision for geotechnical engineer on record. And Dr. Anbazhagan also talked about that we should try to include the site-specific characteristics in the various standards, and the data need to be generated, which should be utilized in our Indian standards. So I would like to tell you here that as the national standards body of the country, we are already working on all these aspects. First of all, I would like to tell that under our Soil and Foundation Engineering Sectional Technical Committee, which deals with the standards on soil testing, subsurface investigation, various types of foundation, their design and construction, we have formulated almost 124 standards and 2 special publications on field and laboratory testing. Joseph Saab said that these standards should be made mandatory, but as you know that the building regulation activity is not a subject of the center. It is a state subject and further vested with the local bodies. So these local bodies basically take the help from the National Building Code of India, which serves as the model code for them. Now, this model code already includes the provisions of having a geotechnical engineer on record. It says that any building which is on a plot having a size more than 500 meters square, or any building which is a high-rise building which is more than 15 meters in height, must have subsurface investigation done by a geotechnical engineer. It also talks about the qualification and competence of the geotechnical engineers. Now, the problem was all these important features which are there, or the important provisions which are there in the National Building Code of India. Not only this administrative aspect, we also have the technical provisions on how to do the subsurface investigation, design and construction. They are covered in Part 6, Section 2 of the NBC, which deals with soil and foundation. Part 6, Section 1 of NBC talks about the loads, forces and effects. And the subsequent sections of this particular part talk about how to design your building with the various material streams. Now, the problem is these important features which are there in the already there in the National Building Code of India, as well as in the various standards, these have not been properly captured in the various building regulations. So as I said, that because somebody talked about professional ethics. So now my professional ethics require that I should keep myself abreast about what is happening in the country and elsewhere, what new things we have to do in the standards. Another thing is that whatever we have done in the standards has to be, that message has to be sent across the states and the local bodies. So what we did a comprehensive study of all the national regulations as well as the international practices, and we have created the draft development and building regulation, because we cannot make our standard mandatory. All standards are voluntary in nature. They become mandatory only when any regulation refer to it, or through a quality control order of the central government or a state government. So because we cannot make our standard mandatory and the building regulation activity is a state subject, we prepared a draft regulations for each of the states and UTs. Now, in these draft regulations, we have highlighted the importance of a geotechnical engineer. We have incorporated the provision that every building which is a high-rise building or which is constructed on an area more than 500 meters square must have the site investigation must be done by the geotechnical engineer, and the report should be submitted to the structural engineer. These provisions have already been incorporated. The provisions on the Part 6, Section 2 have already been incorporated in those regulations, and now we are going to each of the states and UTs. We have done the workshops at for the state of Punjab, Haryana, UT of Chandigarh. Then for this Uttarakhand, we also visited Chhattisgarh, Raipur, and in all the northeastern states, we have planned Rajasthan and all the northeastern states, Patna, Bihar and Jharkhand, we have already planned in the month of April. So we are going to 20 cities with the draft regulations, draft development and building regulations for the states, each of the states and UTs, and trying to propagate this message to them that kindly adopt these regulations, because after this Josimat incidents, as well as the Turkey earthquake, the kind of devastation they have witnessed, and we have also witnessed the recent earthquake in the Delhi NCR region. We should be very careful in whatever we are doing. Now this particularly calls that we need to be very attentive, and all our standards need to be properly followed. These standards are prepared after the collaborative effort of all the various experts who are working on in the field. Anbazhagan Sahab just now acknowledged that we have recently closed the document on IS 2131 revision, which is on the standard penetration test. A lot of improvements have been done in that. So when we went to Uttarakhand, I was completely shocked. There they do not have, occupancy permit has also not been taken by the authority. And they are not at all aware about any of these Indian standards. Forget about 2131, 6403 and 8009. They don't even know the pile foundation codes. So it is really very important that IGS should, apart from targeting these mega cities or the metropolitan cities, they should reach to these smaller cities also. Try to see that the webinars must have experts or the participants from there as well. It is very important to propagate all these standards. So coming to 2131, we got very good useful comments from the members. More than 75 comments came from various organizations. IGS also commented, Parthasarathy ji also commented, and after that we have been able to incorporate the automatic hammers, the safety hammers, the auto trip mechanism. All those things, including energy corrections, have been now for particular project site, based on project site requirements, energy corrections have to be applied. All these kind of provisions have already come in 2131, and it is being sent for publication very soon. We are working on the continuous flight auger piles. We are working on revision of 6403 as well as 8009 pile foundation codes. Not only that, recently we are going to close the various standards on the soil testing equipment. Unfortunately, we had comments only from ML and some of the reputed research laboratories, but HEICO, who are today one of the sponsors, and ROCKDRIL, these people who are already into these manufacturing, I would request they should also come up and send their comments on these documents, because these comments are really very useful in making these standards implementable. So I have requested Suman to share their email IDs so that I can once again send the documents to them for their comments. So these are some of the important works we are doing to support the National Solar Mission, because there is a lot of stress on meeting the SDG goal objectives and targets. So towards the National Solar Mission, the various solar banks or the solar parks being created, they have special kind of foundations needed for those. I would request IGS if they can suggest experts. Already first draft has come from NTPC, but if we can involve more experts in this area for creation of standards on foundations, that would be really great. So I would once again like to mention here that with your efforts, we make standards. So there is a lot of, involvement which we need from your side as well. All our standards have been made free for download. They can be downloaded from our website and from our online commenting portal. From the website itself, from the portal itself, you can comment on any of our published standards. The wide circulation draft for the revision of the standard or for a new standard, they are also these can also be downloaded from our website. On those also you can send your comments online. So kindly time to time you please see these documents, share your comments, which help us in creating better standards. We also ensure that each of our drafts are specifically sent to IGS for circulating it to all the IGS members. So with this, I once again seek for your support, and I would like to close it. Thank you so much.
Thank you, ma'am, for bringing awareness about the improvements brought in by the BAS and the significance of them. Next, I'd like to call up Mr. Pankaj Johri, Director, National Accreditation Board of Testing and Calibration Laboratories, who heads the NABL IGS program for accreditation of geotechnical testing laboratories. Well,
thank you. Very good evening, all. It was very nice to hear all these technical presentation and a good enhancement in the knowledge and how much the development has come in the technology parts for the geotechnical testing. As per the theme of this, this webinar is concerned, very apt that past, present, and future. Normally, when we talk about, I mean, in a as a common person, if you talk about the geotechnical, you will see the buildings, dams, structures, etc. And then we make these person, realize that this is not only the structure which you are seeing on the surface. Actually, it is about the subsurface. And nowadays, with the underground transmission line, the nuclear waste underline, this underground pipelines are they are more into the parts. So the importance of the geotechnical testing, particularly for the future, as the theme is, the theme is talking about, this become more prominent. Particularly that soil and the rocks, nature, the thermal stability part, everything. IGS has come out very at the right time with, to NABL, and they told NABL that you are an important stakeholder in the whole quality ecosystem, and that is very right also, because every time if anybody is talking about the test report issued by a lab, so whether it is accredited or the not accredited, simply the finger goes to the NABL. Whether it was accredited, if it's not accredited, then why not? The first question is why not accredited? So the point here is that like Madhurima madam also told that voluntary nature, that part sometimes restrict the mandate of an organization or the implementation of the standard also. So like that, accreditation is voluntary, but now the regulators and the ministries are realizing the importance of the accreditation, because accreditation is promoting the quality, the accuracy, the preciseness, the confidence and trust of the common people in the results which are in the test results. So in that way, the voluntary nature is gradually turning to a kind of a mandatory one from the regulatory side, from the ministry side also, because now like we have a letter from the Ministry of Roadways and Highway Transport, which is talking about that all the labs who are doing the testing of the building materials in this highway construction, they have to be NABL accredited. So like that, I understand that the importance of the accreditation has been understood by all. Now, when I'm talking about the NABL, and it's an important stakeholder, of course, then why it's so? Why it's so? I think that participants, there may be a student also, they will be benefited if they will understand the importance of quality and what is the role of NABL, standard body BIS and IGS, all this quality ecosystem. See, NABL is granting accreditation as per the ISO standards. So when we talk about and when we say ISO standard, so simple, though it is ISO, but if you if you hear it ISO, so I mean uniformity. So uniformity in the testing pattern, testing standards, testing methods, and the uniformity in assessment of the parameters, how a laboratory is functioning. This is very important. So NABL is granting accreditation to the geotechnical testing laboratories as per the ISO 17025 standard, and 17025 standard, even though it is a general standard and specifying the requirement on a general basis for all the labs, not for the specific like soil testing or the rock testing lab, but still NABL understanding the requirement of this sector, we came out with a draft criteria documents on the geotechnical testing. We have a lot of consultation and lot of inputs, comments from the expert of this sector, and based on those comments and feedback, we prepared a very good very good paper, in fact, that how we can go for the geotechnical testing laboratory accreditation. But now the next question is that how the accreditation to a simple building material laboratory or a soil testing laboratory is different from a geotechnical testing laboratory. This was the first question asked to me. Then, yes, we told them, it's not so that NABL was not thinking previously about the building material testing or soil testing or the rock testing, etc. All these things already were in the scope of the NABL. And there were many laboratories who have that parameters under their scope of accreditation. But when Babu sir, when he came to us, we have a lot of round of talks with him, and in fact, he made us understood that how this sector is important and why NABL is a prominent body in this sector. Then why NABL should, they should take a lead and should approach the ministry and all those things that to incorporate the parameter of the quality in this kind of testing. So we prepared a full matrix, and when we prepared a matrix of the test parameters, all the participants, they may be surprised to know that though you may be technically very qualified persons, more than me definitely, but we understanding about the practicality of the sector. Practicalities of the sector means the infrastructure availability, the facility which are currently available in the laboratory, or which are feasible actually, which are the not putting much financial burden on all kind of the laboratories. So we prepared a set of a minimum possible quality test parameters. And in this set of the minimum possible quality parameters, we categorize some group like group A, B, C, D, which which are the tests which are required to be do on the mandatory basis, or which can be put on the as an optional basis, or which are some of the studies which also needs to be done, because we understood that in geotechnical testing, a role of a geotechnical planner, I think nobody spoke about this. Geotechnical planner in a laboratory, this is very, very important. So how this role and of this particular this geotechnical planner, this can be introduced in our system when we are going to assess the laboratory, how that person is fitted in this, whether it is a quality manager or it is a technical manager or it is a technical persons, and what he is conducting the test or is monitoring the test, what should be the qualification of this thing or qualification of the other technical persons. Because this right point which was pointed out to us, though NABL is leaving out the education part totally to the labs, but still there should be some minimum criteria of specifying that this should be the minimum educational criteria, minimum experience criteria, minimum certification criteria, some training requirement. So if we want to enthuse the quality, then there should be some minimum things. So based on this, we prepared the documents, and accordingly some mandatory tests were, these were there. One of the tests I would like to mention is petrographic analysis. So petrographic analysis, many people were not agreeing to this, whether this should be as a mandatory test, it should be there, or it should be as an optional basis. It's a very important test is there. Then permeability testing is also on the falling head and constant head. Then whether both should be the mandatory, or I mean kind of this thing. What I mean to say is that geotechnical investigation testing, when we are talking about that past, present, and future, it is not simple for the quality point of view. It is a complex issue, still a complex issue that for the quality parts, because the financial parts for the laboratory is also a very important thing. Then the availability of the technical manpower, the right manpower is also a very important issue. Establishing the methodological traceability of the measured result, that is also a very important thing. Then going for the uncertainty part, measurement uncertainty, that should be the minimum measurement uncertainty in the results. That is also a very important thing. So if we, as a quality persons, if we are going to emphasize upon all these things, it means a laboratory should have a highest quality of the infrastructure. They should have the highest quality of the equipments, which is currently not. In Indian scenario, if you say people are going to the equipment of the locally made type of equipments, not everyone is going for the imported one. Or I'm not supporting this thing. Make in India is of course a theme, but at least the quality parts. And then calibration, though calibration is not a big issue currently, but still calibration for the full range of the equipment, for the entire range. This is a very, very big issue. Laboratories are producing the calibration certificate for a small range. So again, this is a kind of a revenue thing, so business interest or something which I don't want to put, go into. But what I mean to say is, it is a complex issue. If talking about the future of the geotechnical testing, we can say it is good, okay, but it is a complex. Why it is a complex? When you talk about the quality in the future geotechnical testing, then it is a complex. Because in the name of the quality, you need to see also the financial feasibility also, the upcoming technology, AI intervention also. All these things have to do, and up to how much a normal laboratory can go. Because 17025 standard is permitting even a single person laboratory. Now there is a catch, because as a single person laboratory, every laboratory, I mean a small laboratory, very, very small fish, they come to us, you grant us accreditation. Then we ask, do you have the persons? Yes, yes, I have the quality manager. Who is Mr. X? Okay, who is the technical person? Mr. X. Okay, who is going in the field? Mr. X. Oh, so point here is where we need to stop, or where we need to put some kind of a lenses, and what kind of lenses and up to what kind of lenses. IGS, Professor Babu, Professor Joseph, Professor Samadhi, and all these big fellows, they are saying, no, you put the brakes, you don't give the accreditation to them. Yeah, still unless even if a one person, no problem. But at least they should be supported by some good technical staff also. But they don't have the equipment of the good quality. I mean all these things, but as a 17011 standard, which we follow as an accreditation body. So as a 17011 compliant accreditation body, we cannot deviate from our established policy and procedures, and we cannot discriminate among the different policies unless it is about the technical competence or the functionality of a quality management system. So point here is how to do it, how to put the quality in this. So here IGS came to us as a big support. I will say a lot of thanks to IGS. They provided us the resources, good professors from IIT, NIT. I mean the list, you say that you develop them as the resources, as the assessors. And as assessors, when these expert persons who actually have a belonging to the IGS, when they are going to the field, when they are going to assess the laboratory, then definitely, even though they would also be sticking to the 17025 requirement, the accreditation standard requirement, even though a sense of quality will generate among the laboratory, I mean sense of complying to the quality requirements, and they would also, their presence itself is enough to see whether this equipment is good enough, whether this person is good enough, whether they are what they are studying, the rock analysis, or analysis, or permeability test, or everything, chemical analysis, or geophysical analysis, or this one, the triaxial, everything what they are doing, whether this is up to the mark. Either they are simply producing the reports or actually doing the test and doing the correct analysis. And based on that analysis, based on the correct, things, they are interpreting the things. So yes, we agreed. And then NABL did, we did a good number of awareness program across the country with, I think, every IGS chapter we did, with every IGS chapter across the country. And we conducted one assessor training program. I think 2 assessor training program we have done it. And we are going to do many more. So it's a good thing, good bonding with IGS so far. And I think from what I heard from Madhurima madam, that it's so much good development on the standard part is being, So I would like, the standard body also, BIS also, to be part of this this initiative what NABL and IGS has taken. And so this much I would say, because I can go up to any length, but the point is the time limit is there. And the main thing is, if we need to bring the quality in this. So what I try to put in here is that there are some constraints, some limitation of NABL as an accreditation body. We are adhering to a standard which is allowing something which IGS can see, no, this is not good for the quality, but we have to adhere to that. In between, we need to chalk out the path. And I think we hopefully, with the help of every expert, we shall be able to do it. Thank you very much. Thank you.
Thank you, sir, for elaborating on the significance of accreditation and the key role of NABL in geotechnical investigations. We have a few sponsor videos to go, and participants, please use this time to drop in your queries. After this, we'll open the session for queries. Thank you, everyone. We'd like to share the screen for the questions. I'd like to hand over to Dr. Partha to lead the panel discussion session.
Yeah, share the screen. If you have any questions, let us see. The minimum number of boreholes in one at the center of site may not be enough, preferably 2 borehole diagonals. So always 1 borehole. We will never do it in practice. Minimum of 2 boreholes. Conducting plate load test for soil determination should be removed. This cannot be removed because this is a age-old method of performing the in situ test to get an immediate settlement, load settlement behavior. Also, you can get dynamic properties of soils. Please refer to IS 1888 and IS 5249 for plate load test. This is the one of the methods to get your subgrade modulus also for our raft foundation, preferably at the base of the excavations, conducting the plate load test to get your spring constants. So please refer to the relevant codes 1888 and 5249. So what is seismic shear strength, seismic refraction? Maybe Professor Anbazhagan, can you please explain? He's been extensively working on geophysical method. Anbu?
See, generally for the in situ measurement, so it depends upon the importance of the project and budget. So if the projects are kind of lightly loaded, one can go for the MASW kind of technique where you can measure the Young's modulus, and then the even nowadays the shear wave velocity versus bearing capacity also available. So that can be used. So if it is heavily loaded structures, one can go for the downhole or crosshole to get the correct in situ properties of the Young's modulus for the settlement and all. And even the density also can be measured, because since you measure the VP, VS and Poisson ratio, so one can arrive very reasonably the density value of the in situ condition. So which will help to design the parameters required for that.
Thank you, Professor. The next question is how to get shear strength parameter sandy soils, as it's difficult to obtain undisturbed samples. Yes, pure sand, cohesion, less soil, it's difficult to obtain undisturbed samples. There are some innovative sampling techniques, particularly the piston samplers, to collect samples even in cohesion, less soils. But generally the boreholes will be cased and then try to collect the samples. But our normal practice of driving the sample, open-ended sample tube, we will not get any good undisturbed samples, particularly in cohesion-less soils. And that's where we resort to determining shear strength parameters of cohesion-less soil from in situ testing. SPT is one of the most widely used in situ testing, mostly applicable for cohesion-less soils. And now that we have standardized that with energy measurement and probably to the required energy transfer ratio of 60% or 70%, you can get very well correlation if you normalize it to the required energy. And of course, CPT test. So now there is also a trend of introducing the piezo cone measurement test CPT, which has very wide correlation for nearly about 50 years, documented correlation based on the CPT testing. So these two methods can be used in the absence of undisturbed samples. Come to the last. Rod length borehole dia correction not incorporated in IS 2131 draft. Is it going to be included in the final version? I'm not sure. Anbazhagan can have answer that. But however, the rod length and the borehole dia corrections is very insignificant compared to the field corrections requiring the energy measurements, which take away all those uncertainties. So therefore, I think it is not included, but the borehole diameter is specified. So I think the practice should adhere to whatever the codes says on the diameter of the borehole. So ETR test, is it compulsory or in the near future? Yes, it is introduced in IS 2131. As more and more people practices and embrace the methods, definitely it becomes a new norm, and going forward in the subsequent revisions, Bureau of Indian Standards will take care of this and introduce this to be a compulsory measurement, because everybody follows that. Okay. So it's same thing. It happened in US, 1980, they started, it took 10 years from 1980 to 1990. And after that, every project adopts that. So therefore, it is based on our voluntary requirement that we adopt for the benefit, and ETR will become compulsory very soon. So what are the possible exploration methods that can be adopted? Where is that? So hold on. What are the possible exploration that can be adopted for the ground having deposits of sand, gravel, boulder mix, where the conventional methods of borehole drilling, in situ testing, SPT is not feasible for the engineering characteristics of the ground. So, so this is a very complex question because the ground also is very complex. So in such cases, you have no alternatives but to.
Partha, I can answer to him. Actually.
Yes, please go.
Yeah. See, the first question regarding the borehole diameter and rod length correction. See, generally this rod length and borehole diameter corrections are initially developed based on the theoretical approach. So where there was a very less instrumentation and energy measurement on different level. So now the many researchers kind of ruled out that so generally the borehole less than so 90 mm and beyond 150, so only needs a correction. So 150 to 100 mm is not much variation you get with respect to N values. But the rod length has a significant effect. Why? Because the many rod connections losses energy to deliver. So which has been experimentally proved and working on that. But as such, these correction what given in the rod length and borehole applicable for liquefaction has to be adapted. For bearing capacity estimation, those things are not required. But eventually these correction factors will be soon changed in the even ASTM. So that is what we see as a ongoing research. So that is the question which I want to answer. The second is that, so whenever you have the sand, gravel, boulder matrix, the boring technique or a CPT or a SCPT is not possible. So those kind of places where you can use a non-destructive techniques, so such as a shear wave velocity measurement, where you get a reasonably the stiffness value which is required for the modeling, because your C and phi value will be very large, or the C value may be kind of even if you take it at 0, the phi value will be very large, but the gap between the this mix should be captured, which can be captured through the seismic refraction testing, a seismic testing approach. That is the more appropriate, where sometimes you get boulders may be bigger, but velocity because of the loose filling will be 180, 200 and all, which is very dangerous with respect to the stiffness concern. So the other question is in situ shear strength of hard clay strata undisturbed, usually not collected due to the occurrence of disturbance or sampling the pressure meter. Any other tests adapted in this case? No, basically the purpose of your the requirement. So for example, you are looking for the modulus of the material or the deformation character of the material, the pressure meter and flat dilatometer will work. Okay, so if you are looking for the cohesion, so it's better to do it with the seismic cone test or the dynamic cone test. So where you get the frictional angle. Okay, so the friction and tip resistance, which will be useful for the design. If you are only looking for the modulus and deformation, you can go for the pressure meter and dilatometer. So pile load test, Partha can answer. So,
so even for these cohesive soils, even with N value less than 30, I think we need to collect high quality samples, particularly in soft to firm clays. You use thin samples, which has the area ratio of about 10% with a little stiffer material, stiff to hard clays. You use thick wall samples. So what we normally do is drive the soils. So usually when you drive these cohesive soils, it gets remolded. And the moment you collect those samples into the tubes and extrude that into the laboratory transportation, those disturbance will not give you the actual picture of the undrained shear strength. So what we normally do in the offshore practice, we push the samples and then we immediately extrude the offshore laboratory and then perform all the requisite undrained shear strength, the water content, unit weight. So you have all the informations on the site. In fact, we build a container of the laboratory test for the high-speed rail project to extrude the samples as we collect the samples. But unfortunately, the client did not agree to extrude the samples on site. So we couldn't use that facility that we prepared the containerized lab. So in such case of a hard clays, if you have the capability of the rig, about 20-ton push force, you will be able to push the samples even to a shear strength of about 500, 600 kilopascals. There's no problem. So very easily you will be able to get that. So once you get even a 30 centimeter of sample, you can extrude and perform your pocket pentometer or you triaxial test to get your under shear strength measurements. Plate load test has against the footing load test always scale effects. It is better that footing load test can be conducted. So you can anchor the reaction loading and get the load settlement curves. We have done some few tests in Bangalore to verify the bearing capacity. So the formulation of code by BIS probably is a good suggestion. So we will summarize and send it to BIS for the consideration.
Yeah, Dr. Parthasarathy, I would like to add here. Actually,
yes, madam.
I could see that there are certain proposals, like one proposal is for this footing load test, and then there is another proposal for this bidirectional static vertical pile load test. So 2911 part 4, which covers the pile load test, maybe in that standard, the proposer may like to send the proposal to BIS so that we can take it up with the committee. Regarding the footing load test also, the similar proposal can be, again, we would request that the amendments which are required in the standard, concerned standard, can be sent to BIS for taking it up with the committee. In case there is a proposal for any new subject, so on our website, there is a link for proposing new subjects. Only thing, they have to visit our website, click on standards, and there they will find another link, propose a new subject. So that form is to be filled up by the proposer so that we can take any new subject in the committee. There is another question regarding high strain dynamic vertical load test. So we would like to mention here that we are already trying to make a standard on this subject, but somehow the consensus is not there in that committee. The user departments like CPWD and NTPC, they are objecting some of the provisions, but we are planning to have a workshop also very soon with all these stakeholders so that we can form our view whether these could be used for replacing the load test, the static load test. The user groups, they are of the view that the minimum 0.5% of the static load test should be carried out, and these should be additional to those minimum numbers. So let us see how and when we are able to conclude this and we are able to achieve the consensus on this subject. Regarding the other the question which was regarding the pressure meter test and flat dilutometer test, there also I would like to mention that all these tests, how these are to be conducted, where and which cases these are to be conducted, which institute test will not be applicable in which case, these are all very well covered in 1892 in very much in detail. We have also a plan to prepare the standards for each of these institute tests separately. Again, as I said, that we would seek support from the experts. They can the IGS can also suggest the names and propose the individual subjects to us so that we can take it up with the committee. Thank you.
Thank you, ma'am. So some compliments, informative sessions. So thank you for the gentlemen.
Thank you.
Excellent. Can you arrange railway geotechnics? Maybe the next opportunities we can target this topic. Is there correlation between bulk density and SPT N value? Probably Anbazhagan can throw some light because he has worked extensively on this correlation. Anbazhagan.
Yeah, sure. So see, actually, whenever we do any kind of institute test, the data we compile and the region wise, this correlation can be developed, which is essentially useful for bearing capacity estimation. So what we have done actually, we have compiled the data from the Indo-Gangetic Basin where we got UDS samples, and also from the global data from the Boer database, which was reasonably matches the most of the soil in this one in practice. So that correlation can be kind of used.
Okay, thank you, Anbazhagan. I think another requirement of BIS to have a separate code for geophysical methods. Probably the question is in relation to the IS 1892, incorporating so many methods, they should have an independent code. For example, MASW, you only have the electrical resistivity and seismic refraction. So these suggestions we will also compile and send it to BIS together with the other requirement. How to identify soft rock and hard rock while drilling the borehole. So it's agree subjective matter unless you have the measurement to verify the bit load and the rate of penetration. It becomes extremely difficult. If you're able to recover these core samples, probably the strength measurements or UCS value will be able to identify. Again, the geophysical methods, the shear wave velocity, if you have done it together or before the boring, you will be able to identify the layering and then verify by the compression test. Anything else, Nandu?
That's it, sir.
I think I've addressed all the questions of the participants. So if there is no more question, I think we can conclude it already.
Questions you can raise.
Yeah, you can share that. So we will summarize these discussions, and through IGS we will send it to BIS as well. And now it's time for us to propose a vote of thanks. So who will do that is Dr. Sumalata present, our Secretary, IGS Bengaluru chapter. Dr. Sumalata.
Yes, sir.
Yeah, thank you, ma'am. Please conclude and propose a vote of thanks.
Good evening, everyone. Respected dignitaries, delegates, and all the participants. I'm honored and privileged to propose vote of thanks for this workshop on geotechnical investigation, past, present, and future. On behalf of IGS Bangalore chapter, I take this opportunity to convey my deep regards and sincere thanks to the guest of honor, Dr. Anil Joseph, President, Indian Geotechnical Society, for accepting our invitation and gracing this occasion. I sincerely thank the honorable speakers of today's workshop, Professor Sivakumar Babu sir, Professor of IISc, Dr. Parthasarathy sir, Chairman of IGS Bangalore chapter and Chairman of Sarathy Geotechnical Consultants, and Professor Anbazhagan sir, Professor of IISc and Secretary of IGS Bangalore chapter, for delivering wonderful lectures and sharing their rich knowledge for all the participants attended this workshop. I would like to thank Dr. Anil Joseph, Managing Director, Geostructural, Srimati Madhurima Madhav, Scientist, Bureau of Indian Standards, and Mr. Pankaj Johri, Director, NABL, for accepting our invitation and being the panelists for this workshop. Thank you very much to three of you for sharing your valuable information. My sincere thanks to all the BIS officials of SGS, HEICO, SGES, PRD, and ROCKDRIL for supporting this workshop. I'm happy to propose vote of thanks to all the IGS members, professors of IISc, and other participants for their participation and support. Thanks to one and all for making this event successful.
Thank you so much.
Yeah, thank you. Tomorrow we have BK Ramaya Memorial Lecture delivered by Professor Madhvi. So it's in hybrid mode. Link has been sent to most of you. So please kindly join us for the memorial lecture tomorrow.
Thank you.
Thank you.
Good evening to all of you.
Thank you. Have a good day.